Hey everybody, this is Baylor here, your chemistry expert. Today's episode is going to be on chemical composition reactions. You'll learn more today on this video than you ever have before. First thing we'll be getting into is nomenclature. There are two types of bonds that you need to know for this, ionic and covalent. The rules for an ionic bond are that the metal needs to come first. The second rule is the cation name is just regular in this. After that, you put the name of the anion and you use the prefix on that with the suffix "ide". The fourth rule is transition metal. If it's used, you're going to use the Roman numeral for the oxidation state and put it in between the cation and the anion. For covalent, you'll put the less electronegative element first in the original name. The next element will come after that with the suffix of "ide", same as ionic. The difference between ionic and covalent is that there are prefixes for both the name of the first element and the name of the second element. And those prefixes are mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona for 9, and deca for 10. Here are some examples for what you just learned. BbR3 would be boron bromide. CuCl would be copper 1 chloride, and the 1 is there because copper is a transition metal with the oxidation state of 1. And N2O would be dinitrogen monoxide. Keep in mind, these will all be lowercase letters whenever you use. The next thing I'll be talking about is the types of chemical reactions. The first type is a synthesis reaction. A synthesis reaction is the combining of two elements into one compound. An example of this would be A plus B yields AB. And a real life example would be zinc plus iodine yields zinc iodide. The next type of reaction is a decomposition reaction. It's basically the opposite of synthesis because it breaks down the compound into two separate elements. An example of this would be AB yields A plus B, or H2O yields H2 plus O2. The next type of reaction is a single replacement reaction. Single replacement reaction is when one element replaces another. A metal can only replace a metal, and a non-metal can only replace a non-metal. An example of single replacement is A plus BC yields AC plus B, or A plus BC yields BA plus C. A real life example would be zinc plus silver chloride yields zinc chloride plus silver. This is probably the most complicated of the reactions because there are two types, anionic and cationic. In a cation, the positively charged element is being replaced. In an anion, the negatively charged element is being replaced. Here's some examples. The top one, or cation, zinc is replacing hydrogen. And the bottom one, the anionic one, chlorine is replacing bromine. The next type of reaction is the double replacement reaction. This type is when two elements get replaced, and same as single replacement, a metal can only be replaced with a metal, and a non-metal can only be replaced with a non-metal. An example of this would be AB plus CD yields AD plus CB, and the bottom equation here is a real life equation. One thing that you have to keep in mind about the double replacement is that if one of the compounds is insoluble, there will be a reaction, and if two of the compounds are soluble, then there won't be a reaction. The last type of a chemical reaction is a combustion reaction. Combustion reaction is when hydrocarbon reacts with oxygen gas. The equation for this is CX HY plus O2 yields CO2 plus H2O. So there will always be carbon and hydrogen in the first amount. It's just a matter of how much you have of each. The second is an example. It's methane, which is CH4 plus 2O2 yields CO2 plus 2H2O. Now that we're done with the chemical reactions, the next part of the video is going to be a quick definition of a catalyst. A catalyst speeds up the chemical reaction without being consumed. It works by providing a different route for the reaction. Now I'm going to do an explanation on the coefficient and suffix placement in a compound. Here's an example where 3 is the coefficient and 2 is the suffix. Keep in mind, the suffix obviously cannot be changed because you cannot change the amount needed to fill the valence electron, but the coefficient can always be changed, and it'll need to be changed when balancing equations. The rest of the video is going to be about balancing chemical equations. Examples for these will be after the rules, but the rules are pretty simple. First rule is to determine the correct formulas for all the reactants and products in the reaction. The second rule is to begin balancing with the most complicated looking group. A polyatomic ion that appears unchanged on both sides of this equation can be counted as a single unit. The third rule is to save the elemental reactant, which is also known as a single element, and the products for last, especially if it's hydrogen or oxygen. You definitely want to save those for last. Here are some tips for the rules that I just gave you. First, if you get stuck, double the most complicated looking group's coefficients and try again. Next, make sure that all the coefficients are in the lowest possible ratio. Also, make sure you double check because there are many things that can go haywire if you don't erase your coefficient and put the correct. The first example we have is chlorine plus sodium bromide yields bromine plus sodium chloride. First, we'll start with the left element, which is Cl2. We count how many are on this side, and since there's only one over here, we can balance and put the coefficients in front of this. So we have 2 NaCl over here. Next we move on, since there are 2 sodium elements over here and only 1 over here, then we balance and put the 2 in front of sodium bromide. Next we check bromine. We have 2 over here and 2 over here, so we're all good. And at the very end, you want to double check everything just to make sure it's all worked out. For our last example, we'll do a little bit more complicated one. Here we have aluminum sulfate plus calcium chloride yields aluminum chloride plus calcium sulfate. So first thing we want to do is start on the left, and it's also the most complicated one, so that helps. So since we have 2 aluminum here, and we have 1 here, we'll go ahead and make this right here 2. Next, we'll move to the next ion, which is sulfate. We have 3 here and only 1 here, so we'll make this calcium sulfate 3. Next, we'll check the calcium. We only have 1 on this side, and we have 3 on this side, so this becomes 3. Last, we'll check chlorine. We have it. Make sure you don't get confused, because since it says 3 for the suffix right here, but coefficient, so you multiply 2 and 3, which equals 6. So since we have 6 over here and 2 right here, and we already have 3, so that also equals 6, so it checks out. So make sure, we'll check everything again,
and it looks good.
Thanks for watching Chemical Combustion Reactions with Baylor.